Okay, the search for player methods are next. So the first thing we want is we're going to search for the player. And what this is going to do is going to get the angle related to our field of view. So we want to go if vector3.angle, and then brackets, vector3.forward, comma, transform.inverse transform point, and then we're going to use the player locate instance player position. So this is our player location, the player position, and if that is less than our enemy data field of view divided by 2, so our field of view is 120 degrees, so that's 60 degrees to the left and 60 degrees to the right. If we meet that condition, we want to check the view distance. So we can just use a simple vector3 distance.check, which would be our player locator.instance.player.position and our current transform position. If that's less than the enemy view distance, we're going to check our line cast. Okay, now the line cast is going to be what goes between the zombie and the player, and we've got our enemy obstacles layer, so if anything on that layer gets in the way, it'll break the line cast and the enemy won't be able to see you. So if physics.linecast, and it wants to start, end, position, our raycast information and a layer mask. So our start position will be transform position, our current position. The end of the line cast will be the player's position, so player locate.instance.player.position. Out will be the raycast hit, and the layer mask is our obstacles layer. And then we're going to check if the hit transform compare tag equals player, so we know we found the player, we're going to start chasing the player. Else, if we're already in the chasing state, and if the coroutine hasn't started, we're going to set the coroutine set aware to true. So what this will do is, if we hide behind an obstacle, we can't see it, we know we're in the chasing state, we're going to automatically go to our aware state. I hope that makes sense. Sorry if this video is rushed, but my head and heart aren't really into it at the minute, so I'm going to try and get through this all as quickly as possible. It may be a mess, but it is what it is. Okay. Now we've got some generic user methods. So we've got our check states, which was, if you remember, we called all the way up in update up here. This is the reason I put regions in, so I can close them all down nicely, so I don't need them again. We go through them all once we finish a script. So we're going to got a simple switch statement, so we're going to switch to the state. So if it's in the aware state, we're going to call the aware state method. If it's in the idle state, we're going to call the idle state method. If we're in the roam state, we're going to call the roam state method. And if we're in the chasing state, we're going to call the chasing state method. Underneath that, we're going to constantly search for the player. And we're also going to check the attack state. And down here, we've got a private float, random float, with a float for our maximum range. This is just going to return a float value, so we get a random value when we're in the aware state. So not every zombie will be aware for 15, 20 seconds, however long you set it. It'll take a random value between 1 and the maximum range, which will be what we set in our zombie data aware time. Okay, and that'll just return that. So that's all the user methods we need. So if you want to pause and copy that out, I'll close that down and we get to the next lot of methods we need. Okay, these are actually the state methods. Actually typing something for a change. Okie doke. Okay, so let's minimize these for a minute. So the first method would be our aware state, and we're going to check if we're not aware, we're going to start a coroutine called rotate right, and we're going to set is aware to true. In our roaming state, we're going to set is aware to false, and then we've got a switch statement, and we're going to switch depending on our enemy data dot roaming type. What did I call it up here? Okay, I think this is because this is because I've got it all from a different script, so we need to change that to zombie data dot roaming type. Where are you? I can't find it. Is it roaming? No. What do I call it? Yeah, it is roaming type. So why are you griefing me out? Okay. Right, yeah, that wants to be zombie data. It's right, because I've copied these over from previous scripts. I'm going to have a few little errors that we need to sort out while we're going along. Okay, so we're going to switch our enemy data.roaming type. An easy way to do switch statements. Let me just copy that a minute. If you start typing switch, hit tab twice, it will fill this in. And if we do a Control B and paste that in and hit enter, it'll automatically fill out all of our types for us. So there's a handy little tip if you didn't know that. Okay, so we're going to switch our data types, and if it's a random roaming type, we move to a random position, and if it's a waypoint roaming type, we move to a waypoint. Our idle state, all we're going to do is set is aware to false and start a coroutine set idle, and we're going to pass in the enemy data idle time. Our chase state, we're going to set is aware to false. Then we're going to check if the distance between our player and our current position is greater than our enemy data escape range, and we're not already in a coroutine and we're not alert, we're going to start our set aware coroutine. Else we're going to do agent dot set destination, and the destination it wants is the player position. And finally, our final one is our check attack state. So if vector3.distance, our player position, our current position is less than enemy attack range, we're going to set our can attack ball to true, else we're going to set can attack to false. Okay, so if you again want to pause, copy these out, there's those. Okay, the next lot of methods we need, these will be the actual movement methods to move the nav mesh agent. As you can see, again we've got quite a bit, so I want to nick zombie data from there. So first method we've got is reset roaming. We're going to stop all coroutines. Then we want to set the agent speed, so agent.speed, and we're going to set that equal to our enemy data dot roaming speed. And we're going to set our state to roaming. And then we've got our switch statement again, depending on what type of roaming we've set our zombie up to. So it'll be, if random, we're going to do a variable random spot equals random position, and then we're going to set our agent destination to the random spot, else we're going to do var random waypoint equals wander spots, random range from 0 to our wander spots count. Then we're going to set the agent destination to a random position and our random waypoint. Okay, next one will be move to waypoint. So we're going to check if we haven't reached our destination, which is a ball we've got down here. So that's just basically a private ball has reached destination, and that's going to return our agent.remaining distance is less than or equal to our stopping distance. Now, if we use vector3.distance in this, you'll get all sorts of errors after 2 or 3, even up to 20 times. It will start returning infinity, so we need to use the agent remaining distance. So where was we? Move to waypoint, yeah. So we're going to check if we haven't reached our destination, then return. But if we have reached our destination, we want to create a new wander spot, so it's just easy to do var new spot. Again, would be wander spots random range 0. And our wander spots count, and then agent dot set destination to a random position within this new wander spot. Okay, move to random position will be the next method we need, and it's pretty much identical to our move to waypoint. We're going to check if we haven't reached a destination, we'll just return. If we've reached a destination, we need a new spot to go to, so we're going to pick a random position, and then we're going to set the agent's destination to the new spot. Okay, so we've got our random position methods. The first one doesn't take any parameters, so this is just for a random position. So we've got a private vector3 random position, and we're going to create a new vector3, we call it random point, and that is going to be equal to random dot inside unit sphere times enemy data dot roaming radius plus a current transform dot position. What inside unit sphere will do, we'll cast a sphere around our zombie for whatever our roaming radius is. And then we're going to do navmesh.sample position. And we're going to pass in, if we have a look, it wants a source position, an out, max distance, and an area mask. So our source position is this random point we've just created. Then we want our out, navmesh hit, nav hit. The radius will be the radius in our enemy data roaming radius. And for our layers, we're just going to use -1. And then we're going to return that nav hit dot position. And then that will be passed to our agent.set_destination. We've also got private vector3 random position, but this one now will take in a variable for a wander spot. And again, it's var equals random direction, and it's random dot inside unit sphere times our spot dot wander radius. So if we jump right up the top, that's our wander spot wander radius here. So that's how far to the waypoint we need to get before the agent will recalculate a new position. And then we're going to add our spot.center.transform position. Again, if you remember, up here we've got a game object we've got called center, which is the actual waypoint itself, and the radius is how far around that waypoint we'll need to reach before we get our new position. And then again we're going to do navmesh.sample position, random direction, out, navmesh hit, nav hit, then our spot wander radius -1, and then we'll return the nav hit position. Okay, so that's all the movement methods. We're finally on the last legs of this script. We've still got a couple more, but we're slowly getting there. Okay, and that'll be our coroutines. So let me close these down for a second. So the first coroutine we've got is our set aware. So we're going to set coroutine started to true. Then we're going to do float time equals the random float, which we made up here somewhere. And that's going to, as you can see, it takes the max range, so that'll be our aware time. We're going to set our state to aware. We're going to set our agent speed equal to 0. We're then going to return and wait for our random time. We're going to set isAware to false. Coroutine started equals true. Agent.update rotation equals true. And we're going to set reset roaming. Set idle, we're just going to set the agent speed to 0. We're going to wait for the idle time, and then we're just going to reset the roaming. Okay, rotate right. We've got our start rotation equals a new vector 3. And we're going to go 0 on the X, our transform position on the Y, and 0 on the Z. And then we want our current rotation, which is our current transform dot Euler angles dot Y, and our end rotation, which would be our start rotation Z plus 360 degrees. We then declare a float t, you can call it whatever you want, and set that to 0. And then we've got a while loop. While t is less than rotation time, we're going to add time.delta time to this float. Then we want to declare another float, our y rotation, and then we're going to alert between our current rotation to our m rotation, and then we want to do that by the time divided by rotation time, and then our little modular sign 360f. And then we're going to set our transform.Euler angles to a new vector 3, and again that'll be 0 on the x, our y rotation here, and 0 on the z, and we just return null. Once that's finished, we're going to start our rotate left coroutine. Again, we need our starting rotation, which would be our current transform position.y, like we've done above here. Again, our current rotation, which is our local Euler angles.y. Our m rotation, which is obviously the start rotation plus 360 degrees. Again, our float t, time, etc, etc, but this time, when our transform.Euler angles, we're going to create our new vector 3, 0 on the x, negative y this time, so we rotate left, not right. You'll return null, and then we start our rotate right coroutine again, and that'll loop round until our alert time is finished. It'll get reset, and zombie will go to its next roaming point. Okay, so that should be it for the agent AI script. So we are on the final last legs. So if we start at the top, we've got a serializable class wander spot, which has got our game object, which is going to be our waypoint, and a float for a radius around it. And then we've got another class, wander spots, which is going to have a string for a spot ID, and then that's going to take a list of wander spots as waypoints. There are your variables that you're going to need. There are your Unity base methods. They're the public methods, the start, chase, alert, and kill enemy methods. Then we've got our search for player methods. Then our user methods, which is just the check states and the random float. Then we've got our state methods. We've got our aware state, our roaming state, our idle state, our chase state, and check attack state. And then finally our movement methods here. So we've got our reset roaming, our move to waypoint, our move to random position. Then we've got our two vector 3s that will return our random positions, and our ball that tells us whether or not we've actually reached the distance or not. And then we've got our coroutines. So we've got one that's going to set us in the aware state. We've got our idle state coroutine and our rotate left and right coroutines. So we can now save that one. and we can work on the zombie script.